Going into our last section of Chapter 2, Section 5, Compound Inequalities. So we'll be building on what we've just finished, and the key to all of this is some of the words that are very useful in mathematics, and that word is and that word, another, is or. Now, the word and is we are bringing two inequalities together, and in a sense, a compound inequality. And the word and then when we use the word or, have particular meaning, and this is what we'll be looking at here. The word and the symbol for this in math is sort of an upside down U. There's the symbol. This is for intersection. That we're saying we're looking for the intersection of these two inequalities. Now when we see the word or, and the symbol for that is like a U, and that is a union. And we'll be getting to that in our text as well. Now often when this is presented, they use what is called a Venn diagram, and you'll have one set of items, let's say set A, and then another set of items, set B, where they overlap. This would be a Venn diagram of intersection, and that's what they're featuring here, but they're not quite putting it in a Venn diagram. All right, some background. So in example 1, they're giving us a statement in set builder notation. They're saying set A is an even number greater than 0 and less than 10. Now, often what I would do if I were a student is write it out like so. This is set A. So this would be in roster notation. Here it's in words, sort of a definition, in set builder notation. Now they're defining set B as 3, 4, 5, 6. And now they're saying find set A intersecting with set B. So what you do is you look at both sets and say which elements are found in both sets. Well, 2's not found, but 4 is. It's in both sets. 5, no, but 6 is. So the intersection of these would be this, and you would write it in roster notation. Now in example 2, or objective 2 first, solving compound inequalities containing and. So the key word is we're looking for intersection, and we have these inequalities. So in theory, we're going to say, well, this is 5 right here, and it's saying x is less than or equal to 5. So we're going to put a bracket there a line this way, and there is this graph. Now we take our next inequality. X is greater or equal to 3. So that would be about there, a 3. Again, a bracket, and it looks like this. Now if we put the 2 on this line, that is the 3 there, and the 5 there, and remember this one had a line going this way, and the 3 had something going this way. The place where they intersect or overlap is between 3 and 5. And placing that in set builder notation, this is what they are illustrating here. So anytime we're solving compound inequalities and they contain the word and, which is intersection, it's where their lines would overlap on a graph. And we've done things like this in the previous lesson. This is how it's illustrated to show intersection. Now in our textbook they give us this helpful hint that if you were to write the compound inequality this way, putting the and in the center, notice that x is there also. You can put it into a compact form, and this is the form we saw in the previous lesson. This is an intersection, and then an interval notation would be like so. Going on now to example 2, we want to solve these, keeping in mind the word and is there, and this is an intersection. So we can just look at this. We're going to transpose the -7. This will become a 9. So that's this one. We're going to subtract a 1 from both sides. This gives us an 8. Divide by 2. This gives us a 4. So there are our 2 inequalities that we could put now on a number line. Now they're showing the results in set builder notation, but these are what we're going to plot. Now notice it's x is less than 9 and x is less than 4. So if we put the first one on, x is less than 9, it looks like this. X is less than 4 looks like this. So they're both going in the same direction, but where are the lines on top of each other? Where are they intersecting? Well, they're only intersecting in this purple area as you project down onto this third line. Because they're not intersecting in this part, we eliminate that, and we just want the area of intersection. So when we write this in interval notation, it's coming from -infinity, comma, up to but not including 4. That's why we're using a parenthesis. On to example 3. Again, we have this inequality and this inequality and the word A and D, and. So this is intersection. So we solve this by dividing both sides by 2. We get x is greater or equal to 0. We're going to transpose the 1, becomes a positive 1. Add it to -9 gives us a -8. Divide by 4. This gives us a -2. So we plot the first one. X is greater or equal to 0 would be a bracket, and then to the right. The other, x is less than or equal to -2, so -2 bracket, but this time going left. And again, we project onto a third line, or mentally, where is the intersection? Where is the overlap? Well, there isn't any. Well, when this happens, and you have an and, that is, an intersection, there is no intersection. How do we illustrate that? Well, it's going to be what is called an empty set. That is, there is no intersection. The circle with a slash is an empty set. Now, another type of example we're going to have here in example 4 is something that looks like this. And I've written it out. So what would be the strategy to solve something like this? Well, the key is to isolate the x. So here we have to subtract 4, but to keep it balanced, we have to do that from each part of it. And I suggest this technique. So this will be a -2 is less than a -x is less than 3. Now, we want to solve for a positive x. So we do that by dividing everything by a -1. Now, keep in mind, we are dividing an inequality by a -1. When we do that, to keep it true statement, we have to reverse the direction of our inequality signs. So right now they're pointing to the left. By dividing by a -1, we get them to point to the right. Now this becomes 2. This becomes a positive x, and this becomes a -3. Again, I would strongly recommend that you put that from the lower on the left. So we're going to just switch everything around. -3, and the point goes through the -3, and now the point goes to the x, so just rewriting it this way. And then now we can see that we have a -3 that we're going to use a parenthesis for, 2 that we're going to use a parenthesis for, and then we fill it in. So in interval notation then, it looks like so. Now they're doing it horizontally. I like the idea of doing it vertically. But again, that's an option. You can do it this way as well. Now in example 5, they've made it just a little more complicated, but it's not going to be complicated to work it out. So as we see here, we have an inequality with fractions. So we're going to multiply every term by the lowest common denominator, which is a 3. So we're going to multiply this by a 3, this term by a 3, this one by a 3, and this one by a 3. So canceling this out, we've got rid of our fractions. So now we have a -3 is less or equal to 2x plus 15 is less than or equal to 6. Now again, same procedure. We want to isolate the x term in the middle. So we're going to subtract 15 here. We're doing the same thing to each part of our inequality. So this is a negative 18 is less than or equal to 2x is less than or equal to negative 9. Now, again, we want to isolate the x. So we're going to divide this by 2, each part by 2. So this gives us a negative 9 is less than or equal to x is less than or equal to a negative 9/2. So if we take a line and then put our values, this is where negative 9 would be, and this is smaller, so somewhere over here, negative 9/2. This is like a negative 4.5. Then here we're going to use a bracket. Here we'll use a bracket. Fill it in the middle. And then our interval notation will be negative 9, comma, negative 9/2 bracket. So where it may look a little complicated, hopefully this helps to understand what's going on. And whenever you have an x in the middle, it's going to be something that looks like this, and that is an intersection. Now we had been looking at the intersection of two sets, in which this was the symbol and the word was and. We're now going to look at the union of two sets, and the key word is or. So if we put this into a Venn diagram, the intersection was just where they overlap, but now the union is just to include all of it. And if things repeat, we don't write them twice. We only write them once. So the illustration is A, set A is such, or x is such that x is an even number greater than 0 and less than 10. Well, there's set A, 2, 4, 6, 8. Now, set B is 3, 4, 5, 6. And you want a union between them. So you just now incorporate everything. The 2, the 3, 4, 5, 6, 7, 8. Well, I got carried away with the 7 here. I apologize. So here they are. So these are your even. This is set B. And we just include everything. And even though 4 and 6 were found in both and are written in a sense twice, we only write them once. So once again, 7 is not there. Now, as we put this same data that we had before in an earlier one on number lines, we see this is x is less than or equal to 1. This is x is greater or equal to 3. There is no overlap, so there's no intersection. But when we do union, we project both of these down, and we see no intersection, but we definitely have union. So how would you write that? And the answer is, we would say that here it's coming from negative infinity, this one, goes up to 1 with a bracket, and then there's this space. how do we link that space together? Well, we use the union symbol, and then we pick up on the other side, which is bracket, or brace I should say, 3, comma, positive infinity, parenthesis. So where this, if it were intersection, would be an empty set, with union we include everything. And we use that union symbol to link the two parts together. So in example 7, we're going to solve this. Transpose the negative 3, makes it a 13, divide by 5. So this is part. The word or indicates union. And transposing the 1 as a negative 1 on this side becomes a 4. Then this is our other part. We graph them on a number line, and there is no intersection, but since this is an or, a union, we then put that in interval notation, joining our two parts with the symbol U for union. Now in example 8, again, we're solving this as a union. We solve each part, and we get x is greater than negative 1, or x is less than 6. So we do this graph, we do the other graph, and when we move these down into one line, we notice there's a little section of overlap right there, but it makes a continuous graph going way over there and way over there. Well, what's there? Well, this would be from negative infinity to positive infinity, because they actually overlap and then continue in both directions. So what is the solution then for the union of this? Well, they're saying the answer is all real numbers. When you get something like this and its union, the answer is all real numbers. And set builder, well, interval notation is this. Now in set builder notation, we should probably do that every once in a while. So brace x is such that x is all real numbers. I didn't do that too well, did I? Anyway, okay. And this takes us to our vocabulary and exercises. So let's move on to our mini lecture.